Hello! Have you always wanted to test CODESYS Virtual Control SL or CODESYS Virtual Safe Control SL, but you don't have the hardware or time to set it up and configure it for testing? No problem. You can test our Virtual PLC portfolio directly on your Windows PC. No additional hardware required. In this video, we show you how to set up CODESYS Virtual Control on your PC using the Windows tools Windows Subsystems for Linux 2, in short WSL2. We have created a separate video for Hyper-V. In both, we explain the strength, limitations, and ideal use cases. Additionally, we guide you step by step through the installation and preparation of the environment, each suitable for virtual control as a Docker-based PLC solution. All command line commands can be found in the video descriptions. Due to time constraints, this video only demonstrates the use of virtual control. However, the use of virtual safe control is also possible. More detailed information can be found in our online help in the Safe House scenario. The link to this entry is in the video description. Let's start with an overview of the two solutions and how they differ. WSL2 enables Linux environments to run directly and seamlessly on a Windows computer. It starts within seconds and is deeply integrated into Windows, for example via the network share //WSL and shared clipboard. Thanks to WSLG, Linux applications with a graphical user interface can be displayed directly in Windows. A key advantage of using virtual control is that the setup of WSL is much faster than Hyper-V. In addition, WSL2 is more resource efficient because Docker runs directly in WSL kernel without a separate hypervisor. This allows virtual control to run as a Docker container without significant overhead. Through memory management with automatic memory reclaim, WSL2 returns unused memory to the Windows system, which keeps resource usage efficient. Unlike Hyper-V, WSL2 also runs on Windows Home. However, there are certain limitations. In particular, Layer 2 access is not possible. This means that industrial field buses such as EtherCAT or Profinet IRT, which require raw sockets or special drivers, cannot be executed. Networking in WSL2 is done via NAT, mirrored, or virtual proxy, all of which provide only limited access to the network layer. Hard real-time is also not supported. USB or PCI pass-through and Wi-Fi bridging are available only experimentally through a workaround, with a VM and the hypervisor typically being the better and simpler solution. The preempt RT kernel is also not available in WSL2. To be more precise, the RT function is disabled. While it can be enabled, it is then only available as soft real-time. WSL2 is ideal for development and simulation tasks, OPC UA or MQTT communication, and Modbus TCP applications without a connection to the field level. It is also well suited for initial demos without real I/O hardware or for the use on less powerful laptops. Hyper-V, Microsoft's integrated hypervisor, enables running complete Linux or Windows VMs with their own kernel. This allows you to install your own preempt RT kernels, industrial Ethernet drivers, and other specialized software required for more complex control fieldbus applications. An external vSwitch, VLAN tagging, and, if needed, SR-IOV provide near-native hardware access and allow you to pass broadcast and multicast frames to the VM. Hyper-V offers enterprise features such as snapshots, live migration, shielded VMs, and failover clustering. CPU and resource pinning, along with new jitter counters, for example in Windows Server 2025, enable targeted optimization for tough cycle times. Disadvantages: Hyper-V requires more resources because a separate operating system is started for each VM. This means that startup times are longer and both RAM and hard disk requirements increase. In addition, Hyper-V is only available on Windows Pro, Enterprise or Server. Compared to WSL2, GUI integration is less convenient and remote tools such as SSH, FTP, RDP or VNC are required to access the VM. Hyper-V is recommended if you want to run hardware-in-the-loop field bus protocols with real-time requirements, multiple virtual controllers, cluster environments, or productive edge servers with enhanced security and availability requirements. If Hyper-V is the right tool for you, you can jump to the Hyper-V video via the link in the video description. We will now begin with the setup under WSL2. First, turn Windows features on or off and enable the checkbox next to Windows Subsystem for Linux. Then update WSL2 via PowerShell using the commands listed below. Now install the desired Linux distribution, for example Debian, with the following command. Check the installed WSL version with WSL-L-V. If version 1 is still displayed, switch to WSL2 using the following command. Start Debian via the Windows Start menu. First, perform a system update in the Debian terminal by running. Then install the necessary dependencies for virtual control and Docker with the following commands. Open the configuration file for the SSH server. Uncomment the line permit root login, yes, so that the root login is allowed if necessary. Activate the SSH service. To determine the IP address of your WSL Debian system, use the following command in PowerShell. The first IP address displayed is required for the deployment tool and access. If you want the virtual controllers to be accessible outside of their host device, you must reconfigure them for WSL NetSH. We provide a link to Microsoft Help in the video description. Now open the Deploy tool via the Tools menu and select the Communication tab. Connect on your target device via SSH using the IP address. Once connected, an overview of the device data will be displayed under Device Information. If necessary, you can restart the operating system on the device using the Reboot button. Installed Linux packages can be managed via the Package Management button, allowing you to uninstall or install packages by selection. To install packages, download the corresponding dep or RPM files and install them on the host system using Package Management. Currently, Debian and Red Hat Enterprise Linux are supported. In the Deployment tab, you can install packages and images on the desired platform. An overview of the packages already installed on the device is also available. Installed images for the virtualization environment are clearly displayed. Now install the components you need. In our case, these include the images for Virtual Control, Virtual Edge Gateway, and CODESYS License Server. The tool automatically suggests only those products that are supported by the target device, preventing compatibility issues that may be due to the CPU architecture, for example. Once the installation is completed, we can immediately start using the runtime. In the Operation tab, you will find all installed services, such as the license server, along with their status. You can load and view the CODESYS log. Use the OpenWBM action to open the license server web interface. After logging in with your SSH access data, you can manage your licenses in the CODESYS WBM tab. The license server is required for licensing CODESYS Virtual Control. Here, you store your licenses, which are then automatically retrieved by the virtual controls. The license server can either run on the same device as the runtime instances or on any other device within the network. Create a new instance of Virtual Control and Virtual Edge Gateway in the vPLC area. On the right-hand side, in the Settings area, configure the instances according to your requirements and needs of the individual containers. For example, set the instance to auto-start and define dependencies. In our case, vPLC1 is dependent on vEdge, as otherwise no connection to the virtual controller can be established. Ensure that the IP address of the network license server is configured, as CODESYS virtual controllers can only be operated with network licenses. Under Network, assign the instance to a specific container network. To use Industrial Ethernet, the instance requires access to an Ethernet adapter, which can be mapped in the NIC field. If you are using web visualization, open the corresponding port of the instance. In our example, this is port 8080. Make sure that the settings are saved correctly. Finally, to allow vEdge to locate the vPLC1 instance later, it must also be assigned to the corresponding container network. The Deploy tool allows you to easily duplicate instances. In this example, we are duplicating the instance vPLC1. To avoid conflicts with the source instance, always review and adjust the settings accordingly. You can also export your instance configuration as a file. The description of the instance is stored in a CFG file in the zip file. Now start your instance. You will notice that vPLC1 also starts vEdge, on which vPLC1 depends. Once the status of the instances has changed to running, you can connect to vPLC1 with the vEdge gateway. For this video, we have already prepared the vEdge gateway in the CODESYS development system. After creating the user, you can log into vPLC1, download the application to the controller, and start it. Using the IP address previously used in the Deploy tool, we can now access the web visualization via port 8080. When an instance is no longer needed, it can simply be stopped and deleted to maintain a tidy overview and save resources. If necessary, you can also re-import the deleted and previously exported instances. After restarting your PC, you can restart the WSL2 Debian system via the Debian shortcut. The containers in auto start are then accessible again within seconds. Thank you for watching this video.